Welcome to the lecture series on object oriented analysis and design. We are addressing a very important topic called software reuse, which is holding promise. It is an idea that was there when we started building software. Object oriented gave us the maximum promise that it will happen, but until recently we are not talking about reuse in that kind of a magnitude which tells me that it is worthwhile designing for reuse in terms of what you get out of it. Takes investment, it takes time, it takes that systematic approach. However, what we are seeing most often is what is called opportunistic reuse. Many people regard salvaging as reuse because they avoid rewriting code by salvaging classes and functions from existing applications. This form of opportunistic reuse is definitely beneficial to the software development organization, but it is not the systematic reuse that industry pundits had in mind. It serves a purpose. This was thought of earlier on when we were doing software projects in that many numbers. There was something called project asset library, where we started telling that once the delivery phase is over, just before the team breaks, we talk about what is called a project end phase, where the entire team keeps talking about certain things in that project which are assets for future use. In some format, in some way, we using some notation, there will be what is called a project asset library, a process asset library. This project has given us this many assets, this process has given us this many assets. They are there in the library internal to that organization. So, if somebody is getting into another project, they can look up, browse this PALs, the project and process asset libraries. Some keep them separate, the project is separate, process is separate, but then the quality first initiative always wanted people to look at the process first, that is essential for starting. So, process asset, project asset, some time was there for the project teams, even though even at that time projects were getting delayed in terms of time, projects were costing more in terms of a huge escalation of the cost from the time when it was estimated. All these were true even at that time, but then the life cycle model, everything was like that, saying that come whatever may, the core members of the team will definitely get together and say that these assets were created in the project, these assets were created in the process. It was a yardstick. So, where we keep telling that the project was not that bad a failure, over the next 2-3 years these assets will accrue to the value of that project done. It did not really materialize, that was not the yardstick that became popular. People were talking about the raw time and the raw cost metrics, not what it can do in 1 or 2 years more. So, the project's life cycle time was shortened, 1 year, 1.5 years, lean projects. Well, essentially we are now punctuating most of the software development pieces as agile, and it is not the reuse, it is refactoring that dominates. So, once again the idea of reuse is on a lull, it is on a slide. There was a boom time, it was promising, but then once we moved over to agile processes, it became completely different. Not systematic reuse that industry pundits had in mind. What most pundits, Brad Cox kind of a people, were envisaging was integrating reusable components, pre-built, fully encapsulated software, just like that IC chip. That was what is called component. Anything below, we are not likely to use the term reuse, talk about salvaging, because a lot of people are doing, it is more in the zone of salvaging a component, a system, an application. That is the granularity at which we think that the original idea of software reuse will pay back and will pay back well. A reusable component can cost 3 to 5 times more to develop than a conventional software, because reusable component cannot make simplifying assumptions about its environment. What is the way in which the present way of developing component differs? Please recall all the use case diagrams. Deployment, by the time I clear the first design piece, best designed piece, the deployment is completely linked to that, it will work there in that deployment. The moment you start talking about reuse, this component works here, but is expected to work in deployments which are not unknown, which are not known at that time. At the time of making the component, we do not know the deployment. So, we are challenging the discipline that we have brought in through UML, Unified Modeling Language, all the deliberations which indicated that deployment must be known a priori. The moment you completed the design, OOAD is over, the deployment diagram is crystal clear where it gets deployed. From this, we want to pick certain designs, well designed components which work here definitely, but we are scoping them for other deployments. How can you make it? That kind of a generosity is proving to be difficult without simplifying assumptions. Why are those assumptions simplifying? Because it is very crystal clear about the deployment. I know that it will work on this machine. I did not anticipate that it should work on an 8-bit machine tomorrow. Whether I need it or not, let us say it is a 32-bit machine. Tomorrow I did not realize it should work on 8-bit machine, day after tomorrow it will be 64-bit machine. So, how do I know? So, if I know precisely that the 32-bit machine, I can commit a lot on that component. So, it's something like telling wherever in India you are going, it is 50 hertz, 50 cycles per second is the electricity supply. So, a component called this converter, people coming from abroad, they work on 60 hertz. So, there is a small component, most of the times we get a lot of good speakers, it is a common requirement in the university, they are not likely to carry that component. Most conference organizers have these common components stocked, we will have that as a stock and then we will put that once from 60 hertz to 50 hertz, otherwise nothing charges for them, it simply does not charge. Well, gradually we think that these components will become popular, not only the conference organizers, but everywhere that component will be there, you have to simply write your name, pick that component, hopefully that is the reuse off the shelf, all that component is there in large numbers, you have to simply write your name, collect it and go. Well, with every simplification a major responsibility will come, that is the reason why we are wary about simplifying assumptions in software. Even if it is for a good purpose, organization wise too much of simplification is not really considered good, we need to drill some disciplines. So, therefore, we have been telling the same, that the reusable component cannot make simplifying assumptions about its environment even in the first deployment. Therefore, we keep telling that it should be a good sizable component, not some simple component, they do not pay off. A good component with good functionality, almost equivalent to a system, almost equivalent to an application, that is the size of the component that pays back. Long term thinking and vision is often hard to come by in an industry where market windows for products may be open for fewer than 6 months, that is what I have been trying to tell, 1 year life cycles, 6 months most of the time, lean teams dominated by agile. This is not due to narrow vision and greed on the part of management, it is simply the economic reality. Software economics have gone that RE for many reasons, not because lack of vision, not because of lack of technical depth, but just the business reality. Therefore, it is now becoming very important that what we have done earlier should combine together to give us complexity. A company working to create reusable components for its product will be beaten to the marketplace. It may have a long term economic advantage over its competitors, but only if it survives for the long term. People are very wary in the software industry today to even talk about 2 years. 2 years is a big time. If the faster moving handcraft company gets to the marketplace first, it will establish market share and may be able to crowd the first organization out. So, these are certain things. What is it that gets your you have to create that market? These are all different topics. I only gave example of one brand Vivo, but then it is like that next 10 days it is coming, people are eagerly awaiting. I do remember in the early 90s we were talking about what are called software development kits, SDK. The announced software will take some time to come. All of us were wary even at that time that software delays are inevitable. They are telling that a particular piece of software, application software, is likely to be in the market by so and so date. Past track record of the best of the organizations tell that they will invariably be delayed. For how long can we wait? And if you make the application software purchasers wait, they will lose interest in it. Why should I need it? They will find some other way, later on we will buy. So, a good marketing ploy by the application software developers was what was called an SDK, software development kit. This particular software development kit is available for free download, but then you have to wait. That was the expectancy that that package was creating. People will firm up their ideas to purchase also. So, this SDK was downloaded and then we will start working on this SDK. Whatever runs, it is not giving functionality, but it gives you a feel for what that particular application software which is about to come is likely to do for you, for your organization, for what you want to do. Tangibly you will understand that. Then you will firm up your ideas. By the time the piece of software arrives, you would have made your purchase decision and go ahead with that. Some organizations are currently achieving very high levels of reuse, but very few organizations. This is considered one good example where a rapid prototype, which was also at one point in time spoken of as a good reuse idea in the form of software development kit, has given us some kind of a revenue model, but once again we are only talking about component, should be designed for reuse. That SDK will be thrown away, it is of no use for us. One time you will get a feel for application software, but it is not called reuse. Once we start becoming very rigorous and stringent, we should, about the definition of what is software reuse, we do not see much of reuse. Immediately the much of reuse will vanish. Cosmetic reuses, ad hoc, opportunistic, all these things do exist. An excellent example is the software engineering laboratory at NASA Goddard, which routinely achieves an astounding 75% or higher reuse level across any language. So, we think that if we start looking at the principles of programming languages, that factor will vanish. 75% or higher reuse, a phenomenal reuse. We do not want to take away the sheen from the success story at NASA, but we do place this argument saying that NASA is very clear. It builds software only with one single purpose, that is space application. Come whatever may, they will not deviate from their primary requirement for which they started. It is called space applications. Then what are the other verticals? Multimedia was one very promising vertical. So, we started talking about software reuse will happen in multimedia. It is called frameworks, multimedia frameworks. Try to build multimedia frameworks. We think that using these frameworks, anything, whichever file it is, whichever media file it is, it is called what we attempted was media convergence, which is still not there in place. It was a possibility 20 years back. Whether you call it regulatory authorities, whether you call it policy, the media convergence is a good idea which was there 20 years back, which facilitates phenomenal reuse. So, therefore, we tell that if you are talking about a vertical, you will match the speed of making reuse happen to what those chips were making, the hardware. Neck breaking speed, you can rig up something together, test the functionality, very quickly you will get a functionality. There are people who do that. Very quickly they do that, gives you a different functionality. So, we think that if the vertical is there, it gives you faster reuse, but then how many verticals? The next one we were talking about, which will have a high potential for reuse, has been the area of hospital management, health sector, because most of the aspects related to health are common wherever you go, and they should be common wherever we go. It is something which we are promising, that health sector, multimedia, they are potential verticals where reuse can happen at a very, very quick pace. Been talking about that at a very quick pace. We were supposed to get that productivity jolt from third parties who would create catalogs of reusable components, which the equivalent of software original equipment manufacturers would then assemble into applications. That is what I have been trying to tell. Please visit any electronic laboratory, you will find in those nice boxes, arranged in boxes, a lot of integrated chips. Can make many circuits, many combinations. Please go back to that example of Meccano with about 30 to 35 different components. They will create lot of figures, lot of artifacts can be generated. Computer graphics was one other one. Libraries, library routines, where the vertical is there, reuse can happen, but that is not the kind of reuse which we wanted in the beginning. We would wanted something to be as matured as an IC market. It should be a more like a component factory. So many pieces are required, not many components can be reused. That once you become very stringent on software reuse, that is one reason why the scalability of the idea of software reuse was not seen, even though we created a variety of software engineering called reuse based. Every instinct we have as programmers screams out that there must be common components for software applications. Whenever we start doing the piece of software afresh, yeah, this we have been doing for ages, what can we do without input and output? Is there some way of making it happen just like that on the fly? Most programmers know that it is rare to create something truly new. So, we have been talking about some recent AI applications. There is no input, there is no output, it is just a signal. One signal, one action happens. Just one signal. There was a very nice idea called gesture based computing, Kinect programming. Microsoft has come up with this Kinect programming. All these things are very good examples of why object oriented is something which is so fascinating. All these in recent times they have gotten a very good fillip and they have been working on that. Most programmers know that it is rare to create something truly new. All of us tell the same thing. We are not likely to create something totally new. A good example is how many different, completely different, unique application software pieces have happened in the recent past. Not many. So, out of 30% stable requirements, it is not entirely outlandish to think that at least 10% we are familiar with, they have to be done. Out of 30% frozen requirements, 1/3 of it, whatever you do, wherever you go, they have to be done. There is no escape from that. So, we do that. Good software professionals keep a mental backpack filled with previously used concepts they can apply when a familiar sounding new problem comes along. Now, the concern here is that the technology is there. As I said, these days we are talking about AI, just a signal, only a signal is necessary, the corresponding code automatically gets developed. Gesture based Kinect programming, gesticulations are enough. Well, are we doing that much or not is something that is secondary, but in theory yes, we only see some gestures. That gesture is getting connected into lines of code, converted into lines of code. Those code bases will be available, we can combine in whatever way we want. Therefore, what is it that we talk about? We talk about imposing intelligence on the otherwise dumb machines. We will have to create that layer of AI all these are very necessary, very essential. The moment you see code bases floating around, we should also have that discipline. Otherwise, what is the reason why we are worried about? We tend to become context free very fast in the field of computing. We are doing well when we are directing our designs to a known deployment. Once we start talking about genericity, we are once again losing out on the discipline of bringing the context into what we did. If you are out of context, you are out of context, we can't do anything about it. Object technology seems to offer the tools to reuse. That is the reason why we keep telling that it is not only the maximum promise, it is the maximum discipline that object oriented analysis and design brings in. Object technology seems to offer the tools to reuse these concepts as reusable components. That is a component, one gesture is a component. So, we said that it does not have good return on investment, you do not have much of a business purpose. I am doubtful, I doubt if there is a serious business purpose outside of a granularity of component, an application, a system. It happens, there is opportunistic reuse. Each time we also encourage our students, if they find that sir this particular function is there, I would like to reuse, this phase project was doing this, I will pluck it and reuse. Good ideas, they should know that reusability happens. Unfortunately, we may have confused the idea of common concepts with reusable components. It is what I keep telling, that if 30% of the requirements are frozen, you are divinely blessed, out of which 10% will always be there, whichever application you are developing, 10% you will run into frequently. That is not what we are talking about as reusable components, should be at the design level. Component vendors must either seek the lowest common denominator in their customer components or let the client modify the component. Most experts agree that if more than 20% of the component must be reworked for its new context, it is more efficient to start from scratch. 20% is very generous, 10% is just about the brink. If you have to do more than 10% of rework, just throw it away. That is the case in the normal context. However, lot of research is going on what is called white box reuse. The white box reuse researchers claim that we have built wonderful tools, just do not worry about how much of things should be changed, we will simply change. What is it that you want to do with this existing code? Debates are there, controversies are there. It is good to work with noted research schools in these areas, so that you will get a viewpoint, you get a way of talking about it. It is more efficient, you get the good perspective of ground realities. It is more efficient to start from the scratch if it is 20% more. That is what my own experience says. 10% they draw a line. This is some theory that 20% of the code in white box can be changed. In practice, most practitioners say 10% is the brink, whatever be the metric, just do it afresh. That is what is the thumb rule. There have been some successes in creating a commercial component market. Numerous infrastructure components are available for easing the construction of applications. Now, this is what we have been talking about. In many areas, good science and research first ensures definitions. Cloud computing is a very attractive idea. The scalability which it is offering is great. We never thought that suddenly at the drop of the hat you can get 50,000 machines more connected or 1 lakh machines more connected. We keep talking about such ideas. There are 3 successes, others are also there. We are talking about a platform as a service, talking about infrastructure as a service, talking about software as a service, tomorrow desktop as a service, day after tomorrow security as a service. Several service oriented architectures are happening all along. Numerous infrastructure components are available for easing the construction of applications. It is definitely possible. But then what is it that we are talking about in terms of doing with that reuse? That requires a good hold on the design. You should know how to design for reuse. Design is the fulcrum. A recent catalog listed Windows development components such as grid controls, charting and data visualization as reusable components. Well, that's Microsoft Windows, they will define. The definition is like that, whatever Microsoft says is a definition. Other vendors offer components for data management, thread management and data sharing between applications. Where people and the product happen together, difficult to beat that combination. We talk about certain people like that, Bill Gates and Microsoft. It is something which is inseparable. Linux and Linus, whatever it is, Jobs, Steve Jobs. Other vendors offer components for data management, thread management and data sharing between applications, but then these are all not so huge kind of reuse applications which we were actually planning for. They happened. So, we said let it be there. Horizontal reuse, vertical reuse, this is more drawn from the world of software development kits and rapid prototyping. We have 10% of many functionalities or everything about 10% functionality. The 10% of many functionalities is horizontal reuse, the 10% of all functionalities is vertical reuse. This is full functionality, but only 10%. Vertical reuse is known in requirements. Out of 30% of stable requirements, 10% will always be there. They are always reused. We never want to call it reuse. That is the concern that we are having. The Puritans, the researchers keep on telling that the definition of reuse itself is stringent. We are not promising much on that definition. Whatever is happening is ad hocism, whatever is happening is a opportunistic reuse, and we are not really talking about the software reuse which we theoretized several decades back. So, unless you use the full paradigm of object oriented analysis and design, we are not likely to qualify it as reuse. Otherwise, please talk about verticals like NASA, like multimedia frameworks, like we talk about the health sector, to some extent transportation. These days, after the very recently, after driverless vehicles, driverless car, that idea came and the cars became lot more intelligent. We got a fillip saying that this will emerge, the transportation domain will emerge as another potential for maximizing reuse. We talked about it, but then we have to wait and watch. Identify domain, identify and classify reusable abstractions, identify design programming language constructs that support reuse, study and formulate language reuse guidelines, study and formulate domain reuse guidelines. Things have changed a lot. When we were studying MTech, mixed language programming was a taboo, it was an idea. If you are using C language, everything in your program must be ANSI C specified, ANSI C conforming, in conformance with ANSI C. It should be like that. Study and formulate language reuse guidelines. Well, as we keep working further, we are attracted with the libraries available in other languages. We want to connect them. That is the first step of violating that simple, pure and elegant discipline of saying stick to one language, take time in choosing a language. Once you have chosen a language, stick to that language. So, we have been talking about multiple language programming paradigms. They were all called very heretic and taboo ideas. Well, we started working together, we saw the advantages, we saw the potential, we started creating different frameworks. .NET framework was one, component object, common object model, CORBA. We will have to talk about those two topics in the next lectures. CORBA, COM, DCOM are now no more being spoken of. CORBA withstood the test of time. Object request brokers, study and formulate domain reuse guidelines, reuse assessment, assess components based on the guidelines, reuse improvement. So, for all these things we have now stringent definitions for reuse in place. What will make good reuse is in place. The domains are opening up, the application domains are opening up. We have been talking about all the one vertical, as I said, health related, drug discovery. Presently, they are promising that reuse is happening in the drug discovery at a rapid pace. You will have to create algorithms, pieces of software. It is an emergency, it is a global disaster that we are facing, health related. So, how do we do simulations, drug simulations and all? Reuse is one core factor, the drug discovery applications. Generality enhances reusability by making the asset more widely applicable. That means, we are moving away and away from the deployment, a discipline which we drilled in object oriented is just getting violated, but we can't help it. It shows good return on investment. Minimum number of components will fit the bill, others do not. Generosity enhances reusability by reducing the cost of adapting the asset to its host system. The problem in software reuse, the principles, methods and skills required to develop reusable software cannot be learnt effectively by generalities and platitudes. To succeed in the large, reuse efforts must address both technical and non-technical issues. It is easier and most cost effective to develop and evolve networked applications by basing them on reusable distributed object computing middleware, which is software that resides between applications and underlying operating systems, network protocol stacks and hardware. As I was mentioning, CORBA, Common Object Request Broker Architecture. One object requires a service, it throws out using CORBA. The object request broker will fit another object that can provide that service, and both of them will transact the service. A service requester, a service provider are connected automatically. It is there, the idea is there, but then we do not have a systemic control. So, there was a trend almost 15 years back. I was associated with a very award winning operating system called Pramathi OS. I wonder if they are still there. Pramathi OS, I think it is still there. Pramathi has created the first middleware OS, and we were doing some evaluations and some benchmarking where it is systematic. Systematically it will tell you. Again, please understand that in the earlier slides I have indicated that systematic reuse is more reassuring than other reuses, including the definition based, because the system will tell you that this is you have done this, you have not done this, it makes it very clear. Impediments to software reuse: economic, retrieval, expensive. Who knows where are the reusable components? So many pieces of codes are being developed even in a small team of 5 members. They themselves do not know how to track. The versioning control, source code control, these are all bygone era. They are coming from a different set of disciplines: expensive, legal, managerial. There are so many concerns which are there. Legal I did not address much, but they are all there. Economic, retrieval, quite expensive to make. Managerial, it costs more, 3 times more it costs. In conclusion, software reuse is proved to be an efficient way to help improving software development quality, productivity during all these years practices. Although it is not perfect, but is still worthy more research effort. We have done some good promising studies in the beginning of software development. Somewhere in the middle we never wanted to emphasize this idea. There is too much of ad hocism, too much of opportunism. Now we saw object oriented is giving us the necessary disciplines. It has come to stay, 3 decades. We have good tools. So, we think that we can address a chunk of reusability that conforms to our definitions, that becomes more systematic. Thank you. We will meet in the next lecture.